So this is the last section of the chapter, 6.9. All right, so for the first part, what we want to do is answer, can we use coordinates to figure this thing out? And if so, how? And what we mean by how is, would we use slope? Would we use midpoint? Would we use distance? Those are our tools. Can we use one of those things to figure this piece of information out? So the first one, can we figure out that segment AB is parallel to segment CD using coordinates? So we have some coordinates for segment AB, some coordinates for segment CD. Could we use those coordinates to decide if those two segments were parallel? Was there one of those tools, slope, midpoint, distance, that tells us about segments being parallel? Slope. Yeah, we can use slope. Yes. Slopes. We'd find the slopes of the segments and see if they're the same. That would tell us if they're parallel. How about if segment AB bisects segment CD? So we want to figure that out. Could we use one of those tools? Yeah? What could we use? Yeah, we could use midpoint. Yes, midpoint. Decide if the midpoint where CD meets AB, see if that's the midpoint. Number 3, angle A congruent to angle B. Could we figure that out? Do coordinates, do slope, midpoint, distance, does any of that tell us anything about angles? No, not really. In general, coordinates don't tell us about angles. I'm going to say no unless, what would be a special case where we could tell two angles are the same? If they were 90-degree angles. Because then we could use slope to figure out that they're 90-degree angles. If each one of them is a 90-degree angle, then we could say that they were congruent. But for the most part, we can't really use coordinates to figure out anything about angles, unless they're 90-degree angles. All right, number 4. We want to figure out if AB plus CD equals EF. So first off, when we write the two points without a segment mark over the top, what are we talking about there? Distance, lengths. So this is saying the length of AB plus the length of CD equals the length of EF. Can we use coordinates to do that? Yeah? Doesn't distance formula tell us about lengths? Yes. We would use distance. We'd find the length, use the distance formula on AB, the distance formula on CD, distance formula on EF, and see if you add those two together, you got that. How about ABCD is a rhombus? We want to use coordinates to decide if this quadrilateral is a rhombus. That's something that we could use coordinates for? What's that? We could see if the diagonals bisected each other. That would tell us it's a parallelogram at least. So we could use midpoints of the diagonals. So that would tell us it was a parallelogram. What else would have to happen with the diagonals for it to be a rhombus? The diagonals are perpendicular. So I'm going to say decide if the diagonals are perpendicular, and we decide that with slope. Is there something else we could do? A different way that we could figure out that it's a rhombus? Yeah? We could use a distance to compare side lengths. And is there another way other than the diagonals bisecting each other? Is there another way that we could decide it's a parallelogram? The opposite sides are parallel. So we could see if sides are parallel. So we could use the diagonals, decide if the diagonals bisect each other and the diagonals are perpendicular. We could also look at the side lengths and decide if the sides are parallel. So deciding if a quadrilateral is a rhombus is kind of a perfect thing for coordinates to do. All right, last one of these. Angle A, we want to see if angle A and angle B are supplementary. Could we use coordinates to do that? No. In general, coordinates don't tell us about angles. I'm going to say no, unless, what would be the special case? If both of them are 90-degree angles. So two 90-degree angles are supplementary. So we could use slopes then to decide if they're 90-degree angles. So a 90-degree angle is really the only time we can use coordinates to figure out about slopes. All right. Questions there? You good with that? So most of your homework problems are these kinds of questions. There's one problem where they ask you to do a proof using coordinates. So I want to show you an example of that. So I'm going to draw some axes here. And we're going to draw a triangle. So I'll do that. And we'll call this triangle PQR. And point Q is at 0, 2b. Point P is at negative 2a, 0. R is at 2a, 0. And I'm going to put a couple of points on here. M and N. And then I'm going to draw these segments. All right, so we're given that triangle PQR is isosceles. And M and N are midpoints. We want to prove that MR is congruent to NP. So M and N are midpoints of those sides of the triangle. We want to show that those two lengths are the same. The other way you might be asked this question is prove that the medians of an isosceles triangle are congruent. Median goes from the midpoint to the opposite vertex. So prove that the medians of an isosceles triangle are congruent. Well, here we have these coordinates. So coordinates are going to be a good route to go. My plan plan, we need to find the midpoints. So first, find the midpoints. And then 2, I'm going to find the length of the segments using the distance formula. So that's my plan. Once I have the coordinates of these points, I can use a distance formula to find the lengths of the segments. So let's do part 1, midpoints. I'll call this x1, y1. And this one, x2, y2. So the midpoints, so n is going to be x2 plus x1, 2a plus 0 divided by 2, comma, y2 plus y1, 0 plus 2b, divided by 2. Well, this is just 2a divided by 2, so I get a, and this is 2b divided by 2, so I get b. So the midpoint n is at coordinate ab. Let's find midpoint of M. Well, I have this one as x1, y1, so I'll call this x2, y2. x2 plus x1, negative 2a plus 0 divided by 2. y2 plus y1, 0 plus 2b divided by 2. Well, this gives me negative 2a divided by 2. So I get negative a, and this just gives me 2b divided by 2, which is b. So that point is negative a, b. So there are my midpoints. That's part 1 of the plan. Part 2 of the plan is find distances, lengths. So let's do MR first. MR equals, since this is x2, y2 already, I'll call this one x1, y1. Use the distance formula, square root. x2 minus x1, 2a minus negative a. Squared plus y2 minus y1, 0 minus b. Squared. Well, this is going to equal 2a minus negative a is 3a squared, and this is plus negative b squared. Now I'm going to square everything. The square root of 9a squared plus negative b squared. We always get a positive when we square things. 9a squared plus b squared. So that's the length of MR. Now let's find the length of NP. Going to do the same process. This is x2, y2, so I'll call this one x1, y1. Do our distance formula. x2 minus x1, negative 2a minus a. And we're going to square that. Plus y2 minus y1, 0 minus b squared. Well, that equals a square root of negative 2a minus a is negative 3a squared. And we get a plus negative b squared. Square everything. When we square a negative, we always get a when we square something, we always get a positive. So negative 3a squared is 9a squared. Always get a positive plus b squared. That is the same as that. So that tells us that MR is congruent to NP. Those lengths are the same. Got the same thing out of the distance formula. So the two segments have to be congruent. And that's what we were trying to prove. So there's one problem that asks you to do something like this on your homework. All right, questions? Okay. So we'll answer questions on this, and then we'll do our little review activity. So there's that. Don't forget that your simplifying radicals due next week on block day. Mm-hmm. Mm-hmm.